Okay, guys, so welcome to the Community Engineering Hangouts. Today we have two really interesting topics connected to some automated testing models and strategies, and how to deal with some infrastructure problems, some issues, and so on. Okay, Soumya, go ahead with your presentation.
Sure. I'll go ahead and share my presentation real quick. Hey everyone, my name is Soumya and I'm a part of the quality engineering team. What we do here is we work on building solutions and tools for improving quality processes for product teams here at Magento. I'm here to present a small talk on the work that we have done so far on the predictive test selection research. So this R&D is really focused on improving efficiency in code delivery process and also reducing the testing infrastructure costs that we see by implementing a change-based test approach. So we've based this research on papers published by Facebook and Google on how they are taming the continuous testing process, especially when they're seeing high feature churn rate and an ever-increasing test pool size. So a little bit about the current state. As Magento is evolving, we're seeing more and more code submissions to the code base, and with that, more and more tests getting added to our code base. So with that, we see a gradual increase in the feedback time on test results and builds. We are also seeing that the test infrastructure costs to run these ever-increasing test pool sizes also increasing. So we've been researching on certain ways to implement a change-based test approach, which means running tests that are relevant to the code chain instead of exercising all tests on builds. So a common change-based test selection strategy is to choose tests that depend on the modified code, right? So according to, say, build dependencies or composer dependencies. So this technique has a significant shortcoming. A low-level code change may select as many as all tests. So to develop a more efficient method, we are considering a different question. What is the probability of a given test finding a bug for a code change? So if we estimate this, we can rule out tests that are extremely unlikely to fail on that code change. So what we did here was we used standard machine learning techniques to train a predictive model with a large data set containing test results on historical code changes that are collected by our MTS platform, our continuous integration platform. So this model then selects tests based on the probability score of a test failing on a new code change. I'll talk a little bit about the proof of concept that we worked on. So what we did was we collected 3 months of functional CE build, which has these MFTF test logs, right? So we collected that from the Jenkins job archive database. So we specifically looked at certain job types like MTS API and existing PRs. The reason why we only considered these job types for the POC is because we could easily find the information for extracting pull request numbers from these logs. From the pull requests, we could get the change list information from GitHub. Other supporting data sets that we used were module dependencies of MFTF tests, as well as module to domain mapping. So this essentially formed the raw data that we worked with for this POC. So from the data we collected, we saw that very few of our tests actually fail, but those that do are generally closer to the code they test. So from the data that we collected, we built a data set containing code change information and test information, test outcomes of those changes to train the model. So we work with the assumption that every new pull request will at least be slightly different from the previous one. However, features extracted from the new pull request can be similar to features extracted from a previous pull request. So by feature, I mean module dependencies, size of the change, number of authors in the pull request, active areas of the code base, failure rates of tests, and dependent modules of the tests. So we built a data set that contained features we extracted from the collected data. We categorized these features as change level features, test level features, and cross features. So change level features were features related to the code change itself. So which included change history of files, the file cardinality, number of dependent modules for a specific file, file extensions, number of authors. Test level features were historical test failure rates that we saw from the runs that we've been doing for these past 3 months. Cross features are features which are engineered from the change level and the test level features. So we looked at features like number of intersected modules between code change and test, number of intersected domains, number of common tokens in the file paths. So this was essentially what the test data set or the training data set looked like. I'll talk a little bit about the model we trained to predict the test failures. So we used a standard machine learning algorithm, a gradient boosting decision tree classifier. So we used very standard machine learning techniques. We did a 70-30 split of the data set such that the most recent records fall into the testing data set and the remainder, the previous records, fall into the training data set. So this way we wanted to ensure that the evaluation, the model evaluation closely represents how the model is going to be used in production. So what this trained classifier then does is it returns a score for each test in the test data, which can be considered as a likelihood of the test failure. So in order to avoid predictions of any false positives, we encounter test flakiness very often in our builds. So we wanted to attempt to not include such flaky tests into the training data to prevent false predictions. So here the term flaky means that the test had at least one rerun in a build. So in our CI system, we have a concept of rerunning a test maximum of 3 times until it passes. It's a deflaking strategy. So we wanted to exclude such tests from our training data set. So what we did was we set a threshold and we removed such flaky tests from the training data. So in machine learning, generally what you do when you're training a model, you also do certain hyperparameter tuning of the model. So what it does essentially is to select the best features that the model was trained on and use that for predictions. What we found was that the best performing model, or the model that was giving us the best evaluation metrics, were considered features like test failure rates, file extensions, change history, number of intersected modules, and number of dependent modules as the strongest feature in the training dataset. So coming to calibration of the model, so we use standard machine learning metrics like recall score to evaluate how the model did on the test data. So in our case, the test data, so we used 3 months of data for this POC, and the first 2 months of data was used for training, and the third month of data was used for testing. So the test data is basically the data extracted from 1 month of pull requests submitted right after the time period of the data with which the model was trained. So we looked at 2 metrics that we were interested in, which was test recall and change recall. So test recall indicates the percentage of test failures correctly predicted in the test data, and change recall indicates the percentage of build failures correctly predicted. So what we found was that by setting a probability threshold score of 0.12, we were able to catch most of the test failures and build failures by just selecting 21% of tests. So what this means was that just by running 21% of tests from the test suites, we are able to catch most of the 99% of test failures as well as build failures. So we are currently looking at, so from the results, the promising results that we're seeing on the POC, we are currently working on high-level design of how we could integrate this into our MTS or the CI platform. So for a machine learning model to work in a build system, we need to have an automated process of continuously evaluating and retraining the model with the new data, the new pull requests that are coming into the code base, and all the runs that are being done on the CI platform. So the model meeting our criteria automatically replaces the one operating in production. So the summary of it is that we save new training data as we receive it. When we have enough data, we train the model, we test its recall against the machine learning model. And if we see that the accuracy of a model is degrading over time, we do some more feature engineering and improve the scores of that model. So some of the next steps that we are working on is doing more testing of this POC, and we are also currently talking to some of the architects on the MTS side, or the platform side, as well as Magento architects to finalize on a high-level design of how this strategy would be implemented with our existing CI infrastructure. We also have several dependencies that we would be outlining and defining. Some of the dependencies are currently in discussion. So the whole idea is that we would be reducing the number of tests that we are running on our pull request and the user-defined, user-requested bills, cutting it down by, say, even 1/4 if we are seeing good metrics, and then have bills that are scheduled on a specific cadence, say every 4 hours, that will run all tests. So we still want to exercise all tests, but the number of but the frequency of it would be sort of on a cadence rather than having it on every build. So there are several strategies that are currently under discussions, and we'd love to keep this group updated on when we have a formalized approach on how we will go about this project. We also are looking at flaky test removal, which is one of the biggest factors that are slowing down our PR processing. We are looking at ways to how to quarantine these flaky tests and not have them run as a part of our clog our delivery process. So yeah, it's pretty exciting stuff that's currently under discussion, and we'll definitely keep everybody posted about the progress that we make. So with that, I will end my talk and open it for any Q&A or comments. Thank you.
Hey guys, any questions? Okay, if you will have questions later, just submit them to the chat and we will be able to answer them. Thank you, Soumya. Great presentation. So, and the next one is Alex.
Hello guys, let me share my screen now. Do you see my screen?
Yep.
Good. So my presentation is not as cool and fancy as Soumya's, but I think it is very important as well as predictive test selection and how we build our testing infrastructure. My presentation mainly gonna be, I'm mainly gonna talk about the problems we have when we test our application with any third-party services, third-party integrations. So first of all, I wanted to start with the current state of what we have when we test Magento integrations with third-party systems. I've got a very simple diagram here, how it works. So as you can see, we have Jenkins job running tests, and inside this Jenkins job, we have Magento container, which basically represents Magento application. And when we do execute our automated tests, which designed to verify that Magento behaves correctly with some third-party integrations, we usually use third-party system sandboxes. For example, if we use, let's say, payment PayPal integration or integration with YouTube videos, something like that, we usually create an account which directs to PayPal sandbox or YouTube sandbox, where we can play and test that our application works correctly. So, and you can say that then what is the problem? Those sandboxes were created right for this specific purpose, so you can test your application works correctly and you have no bugs. So the problems are different. Based on the sandbox, we've got different types of problems. The main problem is reliability of those third-party system sandboxes. Sometimes they are down and not working. Sometimes they are just they cannot handle amount of tests we have, which Soumya just recently showed us and explained us. And there's different problems can appear why those sandboxes fails. The other problem is that recently, in last couple of years, I started seeing that those sandboxes introduced some user rate limits. What it means that you have a limited amount of requests you can send to those sandboxes, and then you just have to pay some money for that, or you blocked executing those tests. Other problem can be, let's say, if this is an integration with PayPal, and when we go through checkout process, when integration redirects us to PayPal UI page, PayPal web page, sorry. Sometimes our tests been written to use specific selector to click a button or do something, and then suddenly they just changed this selector to something else. So test will fail, and that causes a lot of maintenance issues, and basically this is a problem for us. And there's many more other problems we can face with those sandboxes when we have this connection with the outside world. So what solution we found to solve this problem? So what we want to do, and it's currently on proof of concept stage. It's haven't been developed yet, but we look forward to see this being implemented and work fine for us good. So what do we want to do? We want to mock those third-party services. And we decided to build a couple more Docker containers for our infrastructure, which will serve this. The main idea is that all requests which goes outside of Magento will go through the proxy server, and proxy server will, if proxy server will know that this request should be mocked, it will go to third-party service mock, and this service mock will give us necessary response, the response we're waiting for. And it can be anything. It can be any format you can imagine. It can be HTML, it can be JSON, it can be whatever you want, XML, you name it, we do it. And everything else which is not mocked or shouldn't be mocked, or we haven't mocked yet, but we will do this later, we'll go to the World Wide Web and we'll get data from real sandboxes. That's pretty it. This is a very simple idea we would like to implement. And next, I wanted to show you the proof of concept we have and how it works. So what we did. Let me switch my screen real quick. Do you see PHP Storm?
Yeah, I can see it.
Okay. So as I mentioned, we will have a proxy server, which will filter those requests and redirect them to some services, and the service mock itself. So we decided to build to use a basic Docker container functionality where you can specify, and in my example, I will use Selenium Chrome debug container, which will, and in this container, we will try to open google.com and see how we can mock google.com page. So this is the main configuration here. And basically, you just need to execute a simple command of docker compose up, and it will bring everything up, and will do the magic for you. The idea is that when we start Selenium Chrome debug, you can specify environment variables, Docker environment variables called HTTP proxy, and you can specify where this proxy is located. So as you can see here in my configuration, I've got proxy server.docker on this specific port, and there is my proxy.docker container. That's what I have here. I show you later. This will serve as a proxy server, and then I'm having my service mock, and I'm going to mock google.com. So the mock proxy server is pretty simple. This is a Node.js application which creates a server which listens to these requests. And also, when we start up this service, we register all service mocks. So in this environment sample file, you see links to all services mock. And if you have several of them, what you can do, you can specify, let's say we're gonna have Google Docker mock service. You can have, let's say, PayPal.docker. So you can specify any amount of mocking services for your proxy server here. And when you start this proxy server, it will register all of them, and it will know what to do with every single one of them. And then we have our service mock. I won't go through all parts of implementation. I will show you the main part, which is the most interesting for everyone, is how we can put those responses, mock those responses we would like to see. So as you can see here, you can specify you can specify the link you would like to hit, and you can say what you would like to respond here. And you can basically build here whatever you want. If you can even put here your own logic, which will build this response based on the post request you send in to some third-party service. You can do whatever you want, but I've got here a pretty simple example. I will respond that I'm a Google, and if I will go to google.com/test, it will respond I'm a test Google. And as you can see here, you can read get parameters as well as post and anything else. I just don't have here an example for this. So let's run this up. And if it's running, let me change my image. Let me open my Docker.
It looks like it's not real. It started without any errors.
You will see errors soon. Do you see my Docker dashboard right now?
Yeah.
Yeah, good. So as you can see here, this is my main Selenium standalone Chrome debug container, which I use to execute functional tests or do something else. And those three are my mocking services containers, including the separate Selenium Chrome debug. So what I want to show you, I'll connect to this one, which is my main container. I'll go to Google Chrome. Yeah, so this is my main, which is do not have any proxy set up here. And if we will go to another one, which is on different port, then we will try to open Chrome browser. And I know what's going to happen right now. It will show an error. And right now, I don't know why this is happening. Yes, so no internet connection. For some reason, I've got this bug where I need to manually start container after first attempt, only first attempt, but we'll figure that out. And as you can see, that's another container where I mocked my Google. Let's try other URLs. I'm a test Google, and if I will send some parameter here, you can see, you can read those. And at the same point of time, your other container with another browser will work just fine. So if you don't need those mocking to be set up for every single container, you have this freedom. Another beauty of this approach, where is my presentation? Another beauty of this approach comparing to other third-party tools, like we investigated one, maybe you're familiar with it, called Mountebank. But the problem with that is you need to go and configure Magento itself to work with Mountebank. So if you have integration with google.com, you need to find a place where google.com is hard-coded or configured in Magento, change it to link which Mountebank provides you, and then it will work. In our case, you don't you have to do zero configuration for your Magento application. It will work even with those URLs and configurations you've put into Magento. Yes, and this is pretty much it. If you have any questions, feel free to ask them.
Hey, is there a way to log all requests that proxy receives?
I think so, yes. As I mentioned, that's just proxy server itself is a very simple Node.js application. I think we can simply write a logic here which will log all of those requests.
That's cool.
Okay, guys, any other questions? Okay, so thank you, Alex. Thank you guys for attending. The meeting will be available as a recording on the YouTube, on our YouTube channel. Yeah. See you all. Bye.
Thank you, everyone. Have a good one.
Thanks, guys. Bye-bye.
Thank you, guys.